All right, so for this one, it says a 4 kilogram zinc cannonball has been sitting in the desert sun all day. Its temperature is 33 degrees Celsius. Night falls on the desert, and the wolf howls at the moon. That doesn't have nothing to do with anything. And the temperature falls to a chilling negative 20 degrees. How much heat will the cannonball release as it cools the air temperature? The specific heat for zinc is 300 and 390 joules per kilogram. So, anyways, so to figure that out, we need this formula. Where T1 and T2 are the differences in temperature. M is the mass, and then CP is the specific heat. Sometimes you'll see that as a lowercase q. So this is this number here. So we just plug in the numbers. Well, what's the mass? Well, it's 4 kilograms. The specific heat is 390 joules per kilogram per centimeters, or not centimeters, per Celsius. And then you multiply that by the temperature, which is also in Celsius. Now, remember, your final, it's the initial minus, the final minus the initial, right? So technically, it's going to be negative 20 degrees Celsius minus 33, because the initial is 33 and you have the negative sign here. So you're subtracting whatever the initial temperature is. Now what's interesting is this Celsius cancels with this Celsius, this kilogram cancels with this kilogram, and so you get an answer in joules. So if I plug that into a calculator, I get about negative 82,720 joules. Now, how this relates to your current lesson is that we're measuring thermal energy, which has a mathematical relationship between the average kinetic energy of an atom. Okay? So the heat energy, Q, remember that too. I don't know if you guys remember this, but Q is referring to the heat energy. Heat energy and thermal energy are kind of the same, but not really. Heat energy would be the heat energy of the whole thing, where thermal energy that we calculated, that E equals 3/2 Boltzmann's constant, and all the rest of that formula, that's referring to one atom, where this is referring to a mass. Okay? Any questions on that one? So if you know the formula and you know what the things mean, you just plug it in. It's a plug and chug deal.